In this episode, we are going to be finishing the state machine we started in the previous episode. We are also going to be adding the changing of the field of view based on the player's speed, as well as implementing Headbob to make the controller feel more complete. If you did not see the previous episode, I recommend you check it out because we are building off the same interaction system we started there. All right, so welcome back. We're going to go ahead and update our player's collision shape as well as our player's speed. Now, we really want to just do this every time we update our player's state. And every time we update our player's state will be every frame. But we can do it right here. So let's go ahead and do two functions. Update our player's collision shape. I'm going to truncate that. And for us to do that, we need to know our player state. And the other thing we're going to need to do is update our player speed, which also is going to require our player state. So let's go ahead and create these functions just so that way we can get rid of the errors. And I'm going to strongly type this to be the player state. Just like that. And this is going to be the exact same, except we are updating the speed. So let's go ahead and start with the player speed. I think that's a little bit easier to understand. So everything here is going to end up with checking the player state. Now, the one thing we need to do is just put a little underscore under here to make sure that we're using the player state provided by the update player state method, or the method call, I guess I should say. So in the player speed, we need to know a few things. We need to check if the player is crouching or the player is idle crouching. And the reason we want to do this is so that way if the player is crouching or even if they're not moving, we want to make sure they're at crouching speed. Because once again, remember, we are goodness gracious. We are interpolating the direction we are moving, and we are moving toward a current speed. So even if we're idle crouching, we don't want to keep that at sprint speed. Otherwise, the movement can feel a little crooked. So if we're crouching or idle crouching, we're going to go current speed, and we're going to set our current speed equal to our crouching speed. Now, of course, we have our other two conditions. We need to check if the player state is walking, then we want our current speed equal to walking speed. And then finally, we could just do an else. We'll do an else if just to be certain. We're going to check if the player state is sprinting. And if the player is sprinting, we are obviously going to want to update our speed to be sprinting. And we need to make sure we are not misspelling anything. So this should be fairly simple. If we are in a state of crouching, we want to set our current speed to the crouching speed. If we're walking, set it to walking speed. And if we are sprinting, set it to the sprinting speed. We don't need to worry about if we are idle standing or not, because if we're idle standing, we immediately want to get into the speed we want. So let's go ahead and test this and see if it works. So it appears there was a typo in the previous one. This should not be is calling. It should be is colliding. So here we are running. I can still move. It still feels slow, but let's say I go over to the wall here and I sprint. I don't know how well that's going to show up on camera, but you can see we can move, and then if we crouch, we move a lot slower. But as you can see, the camera really isn't affected. We should be crouching down towards the floor, but we're only moving at crouch speed. So let's see what we can do about that. So the first thing we need to do when crouching is we need to update our collision shape. So let's go ahead and go into this method here, into the update player collision shape, and we're going to check a few things. Well, we need to check, we're going to go ahead and just copy this line here. If the player is crouching or if we are in idle crouch, we need to affect our collision shape, which I believe we predefined up here. We did. So we'll come up here and we'll look at our standing collision shape to start. All right, so if the player is crouching or if the player is currently in an idle crouch, we don't want the standing collision shape to be enabled. So we're going to set the disabled to being true, and we are also going to want to grab our crouching collision shape and set its disabled property to false. So oops, we want this to be an equal sign. If we're crouching, we want our crouching collision shape enabled, and if we are crouching, we want our standing collision shape disabled. So obviously you can imagine in every other scenario, we want the complete opposite. So go ahead and just copy and paste these and reverse their booleans. And that's all we need for our collision shape. So before we do anything, let's go back to our player and let's look at the camera 3D. And as you can see, our field of view is set at 75. I'm going to up that to 90 just for personal preference. So when we start the game, we are nowhere near as zoomed in, but our default value is going to be a little important for the next thing we're about to do. So back in the player script, we're going to, around where our mouse sensitivity is, I'm going to create a comment and call this the player settings. And these are the things that the player themselves are going to be able to change. But for me, I want to be able to have a field of view. I just changed it to 90, so let's go ahead and put a variable. I'm going to call it base field of view and set that to 90. Now, if the player wants to have a base field of view at something lower or higher, they can do that. But it's important we have a value to start with, because what we are about to do next is go down to our physics process function, uncomment update camera, and at the bottom of our script, we're going to create that function. So function update camera, and have it just return nothing for the time being. And before I forget, it's actually important that the update camera gets the delta value that is defined as the time between each frame. So that way, if we have a big lag spike, we don't want the camera to go completely out of whack. So we want to make sure we're getting that delta value for the sake of this function. So let's go ahead and start by getting the field of view set for if we're falling. So if we are jumping or falling, we want to check if our player state is in the air, because that's how we define if we are jumping or falling. So if we are in the air, we don't want to do anything to our field of view. We just want it to be whatever we're at currently, because we only want to change our field of view is if we're sprinting or if we're crouching. So if we're sprinting, we want our field of view to increase to kind of seem like, oh, our eyes are wide open and we're running from an enemy. Whereas if we're crouching, we want to be possibly hiding and completely focused. So we're going to narrow our field of view. However, if we're jumping, we just want to keep whatever field of view that we were at before. So let's go ahead and look at the different possible options for what we could be doing with our field of view. So to simplify this process, I'm just going to copy this if-else-if structure from the update player speed and remove the logic between these. And I'm just going to put in return statements for the time being. And we are also going to need to add another, let's check the player state. So remove the underscore. We're also going to need to add a check for if we are idle standing, because we are also going to want to affect the field of view in that situation. So this should be idle stand. So this function is going to control where our camera is as it's moving. Now we are going to add in a head bob a little bit later, but the two things we really need to figure out now is where the camera is when the player is crouching versus when they're standing, and how we interpolate between those two values, and the field of view of the camera depending on whether or not we are running and whether or not we are walking and whether or not we are crouching. So we're going to do 2 lines of code for each of these 4 states. So let's go ahead and start with the crouching aspect. So when we are crouching, we want the camera to drop down here to where we are crouching. Now we did set a variable called crouching depth, and we're going to use that. So what are we actually changing? Well, we're changing the head's position on the y-axis. Now, once again, this update camera here is being called every frame from the physics process. So we are going to want to interpolate between where the head is at this current position on this current frame we are going to, we're going to write 1.8 for now. We can go back and change that later because that is defined as the height of our head when we're standing. And then we are going to want to move to our crouching depth. And we are going to want to move relative to the frame rate times 10.0, which is kind of our interpolation speed. And we can talk about that more in a second. Now, we're hard coding this 1.8 value for now because the head here is at 1.8, and that's the value we want. I don't want to finalize that yet because it could go up or down, and we could do some things for that. But for the sake of this tutorial, 1.8 should be fine. And 10.0 is just a good interpolation speed, which just means how fast we are actually moving from the head position at this frame to the head position at this frame. And this feels like a good value, which once again, we can tinker with as we go through the tutorial. And the other thing we need to do when we crouch is we need to affect the field of view. So I believe we have a reference to our camera, and we should be able to reference our field of view. And just like always, we're going to interpolate from where our camera 3D's current field of view is now. And this is where we needed the base field of view variable. So we're going to take the base field of view and multiply it by 0.95. So this should get 5% smaller. So if it's at 90 degree field of view, it's going to be roughly 86, 87. So it will narrow slightly. And once again, we'll just go ahead and do delta times 10.0. What we're actually going to do, let's go ahead and do this now. Let's just create a variable that we're going to call lerp speed, like that. And instead of 10.0, we're going to call this lerp speed. That way we can change this in one spot and it should feel fairly cohesive. So that'll work for crouching, but we're going to want to do these same lines of logic for all of the other three, just in case we are going from crouching to standing or walking or sprinting. So let's go ahead and do that now. So the good news is the next two are exactly the same. So we're gonna, we're gonna want to copy those and paste them here. So if we're standing, we just want our height to be at our standing height, which is 1.8. And if we are walking, we also want our camera height to be exactly at 1.8. Now, the other thing we need to affect is the field of view. So we don't want to have our field of view change at all. We actually just want our field of view to be at 90 degrees, and the interpolation will handle, if it wasn't at 90 degrees, it'll go back. So these two are nice and easy, and they should be exactly the same. Now, for the sake of sprinting, I'm go ahead and paste in. Once again, we still want the head at this given height. However, we actually want our field of view to increase. So we want to do times 1.05. So if it was 90 degrees, it'll roughly go to about 94 or 95 degrees. And that'll give us the camera will appear as if we're actually running as well. So it kind of adds a little bit of zhuzh to the movement. So let's go ahead and run this and see if it works. So I'll click start. And I'll run, and I can crouch, and you can see the camera drops with me. When I stand back up, it goes up. Let's test our collision shape. So I cannot walk through this wall. If I crouch, ooh, you can see I kind of go into it, but I don't. So let's look at that in a second. I know exactly what that problem is. However, the field of view, I don't know if you're going to be able to see it. So let me come up against this wall. And so this is me just walking. And if I press shift, you can see the camera kind of comes out. And that's going to show that we are actually, sticky keys, wonderful. And that'll show that we're actually sprinting. And then if we're crouching, I don't know if that's going to be able to show up, but yeah, I don't know if that's going to be able to show up. But our field of view should narrow. Maybe that should, yeah, you can see it there. So let's go ahead and look at why our collision shape might look like this and not let us through. So the first problem is the crouching camera height. So if I drag this down to roughly minus 0.65 here, it's not actually on the top of our head. We actually need it closer to about minus 0.8. So let's go ahead and reset that back to the proper camera height. and go into our script and make sure that this is set at -0.8. So now if we hit start, this is at the very top of our crouch height. Now we might actually want it a little lower, otherwise we are still going to kind of clip in. So let's say -9, and we'll see where that takes us. Yeah, so that feels a little bit better. So now our collision shape is still colliding with the wall above us. So let's talk about that. So I don't know if this will show up on camera, but if this is this crouch check wall is exactly 1 meter above the ground and our player is 1 meter, it seems like we should be able to get through. However, those values are only accurate to so many decimal places, and Godot has a built-in tolerance for that check. So what we actually need to do to get this to work is to just set this to 3.01 meters, which seems insignificant to move it up 1/100th of a meter. But if we go into our sandbox and crouch, you can see that we are now under it. So that's just kind of a trick of the engine. But if I let go of control and I just move left or forward and backward, you can see we stay under here. Our player does not shoot up into the wall because they can't. And you'll see if I move to the left, I'll eventually shoot out. So that kind of shooting out motion we can fix later down the line. But the important bit is we can now crouch, we can now run, our field of view is affected, we can jump, and we can move around. So this next improvement is completely unnecessary. If you like the way your player controller is handling right now, you can just go ahead and end the video here. However, I believe that this next feature, which is head bobbing, actually adds a lot to the player character and makes it feel like you're controlling an actual person. Now here in our player scene, we added the head, and the head controls our x-axis rotation. We have the player, which controls our y rotation and controls the whole player moving in the y rotation. So you may have wondered why we added these eyes. I believe I mentioned it, but the whole point is that we are going to head bob, which essentially means we're going to have this figure 8 bounce back and forth across the character, depending on if we're running, walking, or crouching. And that head bobbing is going to happen on the eyes. There may be a better term for it, but that's what I've decided to call it. So let's go ahead and implement head bobbing into the game. So if you like programming, this is about to be the section for you because we need a lot of variables to handle head bobbing. The variables I'm going to give you, I believe, are pretty good, but the fact that there are so many are going to allow you to tinker with them to get the feeling you want. So we're going to need 6 variables right off the bat. They're all going to be constant because similar to the way we cycle between the walking, sprinting, and crouching speed, we're going to cycle between these, but we don't actually want to change them. So the first one is a constant head bobbing sprinting speed. This is a float, and I found a good value to be 22. Now, this is the speed of the head bob along the figure 8 when we're sprinting. So the head bobbing is going to be defined by a sine wave. So if you've ever seen a sine wave, they kind of go up and down in a wave. And so we're going to use the sine function to move back and forth. So this first one, the speed, is how fast it moves. And similar to the other states, we are going to need to do this for the other 3. So we need a walking, which I think a good value is 14. And we need a crouching, which I think a good value is 10. So the next 3 values are actually going to be the intensity. So whereas the speed controls how fast we go through the cycle, the intensity is going to control how much up and down they move. And so if you're sprinting, you want short little bursts, you're in a little panic. However, if you're crouching, you want slow, big ones as you slowly shift to your right foot, shift to your left, and back and forth. So let's go ahead and create those. I'm just going to go ahead and copy this. So we have a const head bobbing sprinting, and we're just going to say intensity. And I found a good value for this to be 0.2. And let's go ahead and add that for the other 3. We have our head bobbing intensity for our walking and our head bobbing intensity for our crouching. For walking, I found a good value to be at 0.1, and for crouching to be 0.05. And once again, similar to the other movement, we are going to need a variable to track where we are in between them, because we are going to interpolate between the various modes. So we're going to have a variable which is going to be head bobbing current intensity, and we are going to make that a float, and we can just say it's 0 for now. And then instead of having one for the speed, we're going to have 2. We are going to have a variable for the head bobbing vector, and this is a vector 2, and this is going to just be defaulted to 0. Now this vector represents the XY representation of where the head bob is. So if you imagine an axis, and here is x1, y1, here is x negative 1, y1, you can chart where we are on the sine wave with XY properties. And that's what this vector is going to do for us. Now the other variable that we need is the head bobbing index. So let's go ahead and create that. And this is a float. We'll set that at 0. And this is just how far along in the sine function that we are in the head bob. And this is important because a sine function moves in waves. It resets on itself. So at the bottom of the graph, it's at 0, and at the top of the graph, it's at 2 pi. And so if you pick an index, you can decide where you are in the sine wave. So here at 0, we're at the bottom. Here we're at 2 pi. Here we're at 0, and everything in between. And I think that's all the variables we need. So let's go ahead and go back into our update camera function and see how we can add head bobbing. So once again, we have 4 different movement states the player could be in at any given time. So let's start with the trivial one, where we control the intensity based on which state we're in. So we care about our current intensity, and we're going to set that to our crouching intensity when we are crouching. And the other thing we need to keep track of is where we are in the head bobbing process. Now, the reason we're not just doing a single head bobbing speed is because we are also going to interpolate between the speeds while we're running. So if I'm sprinting and I immediately go to crouching, I just want to edit the sine wave so that way I enter the crouching state. So let me go ahead and go back into 3D. So let's say I'm sprinting, and I have these short little bursts, right? And so you can see the camera is not centered on my player during those short little bursts. So let's say I'm sprinting, and when the camera's here, I decide to crouch. Well, if I just crouch, the camera's going to shoot back here and then immediately down, and it's going to feel very jarring. What we want is we want the player to crouch and go down. We want this to be a nice smooth movement. Perhaps an easier way, instead of showing the crouch, would be sprinting into walking. So if we're sprinting and we're up in our top right stance and we start walking, we want to start our walking animation from here and go into it. Even if that doesn't make sense, the reason we're doing this index is so it's a very smooth transition from sprinting head bob to walking head bob. So we want to take this index and we just want to keep increasing it. So this one is going to be our head bobbing crouching speed. And then we're also going to multiply that by delta. So that way, if we have a giant frame drop during our game, the camera doesn't get all haywire and just kind of jerk around. It should just go right to where it needs to be when the frames pick back up. So while this seems like a lot, this is now just copy and paste. So now if we are standing, we want to set our head bobbing intensity to walking, which makes sense if you're standing. That's kind of our default. And we want our speed to be set to walking. But once again, we want to be affecting the current intensity and the index. And obviously, we're going to do an exact same copy paste if we are transitioning to walking. And then go ahead and copy and paste again and bring it over to the sprint. Oops. Get rid of any typos you like to add and change walking for sprinting. Let's go ahead and add that here. SPR sprinting. Nope, not sprinting intensity, sprinting speed. So now we have to do some calculations because this head bobbing index needs to actually map to the sign value, which is our vector 2. So how are we going to do that? So after we know exactly what state the player is in and what kind of head bobbing they want to do, we need to manually calculate the head bobbing vector, and we need to do this per axis. So on the Y, we need to look at the sign function, and this is very simple. The head bobbing index represents our quote-unquote X here, and so we just need to get the Y value. The head bobbing X value is also going to be on the sine wave. However, we need to calculate the head bobbing index divided by 2 plus 0.5. So what does this represent? So on the x-axis, the sine wave can be on either side of the player's head, and we want it to go back and forth, right? So when we calculate the y value, we can calculate up and down, but we also need to calculate the x. So if the x value is somewhere down here, the camera should be here. If the x value is over here, it should actually come up here. And so we're manually calculating. So doing the y value is easy, but calculating the x value is a little more complicated. But we just want to know where we are in the sine graph. And that's all we're really calculating here. So now that we have our vector, we need to modify where the camera is. And so we need to know two things. One, we need to know if the player is moving or if they're not moving. And why is that important? To show why that's important, I'm going to go back to our physics process function. So in our physics process function, you can see here, if we have a direction, meaning if the player is trying to move, we want to move at the current speed in that direction. However, if the player wants to stop moving, we don't just want to stop all input because that would bring the player to a jarring stop. We want to move toward 0. We want to move toward not movement. It's the same with head bobbing. If the player is moving and we are moving in that sine functionality and the player stops moving, we don't just want to jerk back. We want to slowly come back to where we need to be. If the player is moving, once again, we are going to do this using the eyes node. So we're going to use our eyes position, and once again, we're going to interpolate. And I'm just going to write this and explain it later. So we are going to interpolate from our eye position. We are going to use our head bobbing vector at y. We are going to multiply that by the current intensity, because that's what we're calculating. We're going to divide that by 2. And then we need to take into account that we need to be multiplying relative to delta. So we're going to move from where our eyes are now to where we want our eyes to be relative to delta. And of course, we're going to want to do the same thing for x. So let's go ahead and grab this. Get rid of the x, get rid of the x, get rid of the x, and we're also going to get rid of the division by 2. So the simplest way to implement this, if we're not moving, we're just going to copy and paste this. So once again, we are moving from where our eyes currently are to where we want them to go. And where do we want them to go? We want them to go to 0 because we want the head bobbing at this point to stop. And I believe that's all we need to get the head bobbing up and running. So let's go ahead and test. And as you can see, as I'm walking, I am moving left and right and left and right. And then if I run, it's moving a lot faster, but a lot shorter. And if I crouch, I'm taking these slow, big, long figure 8s. And so now if I run around my area, I'm jumping, I'm moving, and I want to crouch under here. The player just feels more alive, and it feels like the controller is actually reacting to my input. And there you have it. Our player controller is built. In the next tutorial, we're going to set up our interaction system. We're going to build an interaction controller, and we're going to set up some components that we can easily reuse and copy and paste onto whatever assets we need to make sure we can pick up and throw and grab and interact with the environment we're in. So if there's anything else you want to see in this player controller, feel free to leave a comment down below, but we will be moving on to the interaction system.